Hello friends and welcome to another tutorial on Geeks for Geeks. In this video, we are going to understand the program which finds largest subtree sum in a given binary tree. First, let us take an example. In the first input, all the elements of the tree are positive. Hence, the largest subtree sum will be equal to sum of all tree elements, that is 28. In the second example, the subtree with the largest sum is the one with rooted -2 and left and right children as 4 and 5 respectively. Now let us see the approach. We do a post-order traversal of the binary tree. At every node, we find the left subtree value and right subtree value recursively. The value at subtree rooted at current node is equal to sum of current node value, left node subtree sum and right node subtree sum. We compare current subtree sum with overall maximum subtree sum so far. Next, let us see the algorithm. Let us also have a sample tree to test our algorithm. We pass the root node, which is 1, to find largest subtree sum function. So root will point to 1. Since root is not null, we take an answer variable and initialize it to int min. Next, we call the find largest subtree sum util function with root and answer passed as parameters. Now, in the find largest subtree sum util function, we check if root is null. As it is false, we subtree sum rooted at current node. So we take a cur_sum variable and roots key plus left subtree plus right subtree. So first we pass the left child of 1, which is -4, using a call stack. Again, as root is not null, we pass the left child of -4, which is null. Now, as root is pointing to null, we return 0. Execution for -4 is resumed, and now we pass the right child of -4, which is also null. So root will point to null. Again, as root is null, we return 0 to the previous call. Execution for -4 is resumed, and now we update answer as max of answer and current sum. Since cur_sum is -4, answer will be -4. We return cur_sum, that is -4, to the previous call and finish execution for node -4. Execution for root equal to 1 is resumed, and now we pass the right child of 1, which is 3. So root will point to 3. Since root is not null, we pass the left and right children of 3. So first we pass the left child of 3, which is 6. As root is not null, we pass the left child of 6, which is null. Now, as root is pointing to null, we return 0 to the previous call. Next, we pass the right child of 6, which is also null. So root points to null. Again, as root is null, we return 0 to the previous call. Now cur_sum becomes 6, and since 6 is greater than -4, answer will become 6. We return cur_sum, that is 6, to the previous call. Execution for node 3 is resumed, and now we pass the right child of 3, which is 2. So root points to 2. Since root is not null, we pass the left child of 2, which is null. So now root will point to null. Now, as root points to null, we return 0 to the previous call. Next, we pass the right child of 2, which is also null. Again, as root points to null, we return 0 to the previous call. Now cur_sum for root equal to 2 is 2, and since it is not greater than answer, we return cur_sum to the previous call. Execution for root equal to 3 is resumed, and now cursum for 3 will be 11. Since cursum is greater than answer, answer will be updated to 11. We return cursum, that is 11, to the previous call and finish execution for root 3. Execution for root equal to 1 is resumed, and cursum will be 1 minus 4 plus 11, that is 8. Since cursum is not greater than answer, answer remains 11 and we finish execution for 1 and return 11, which is the final answer. With this, we come to an end of this tutorial. For any doubts or suggestions, please leave them in the comment section below. Thank you for watching.